Okay, so we're going to be learning about combined events, carrying on with probability. So hit pause, copy the lesson objective and the keywords down. When you're ready, hit play and we'll move on to the starter. Okay, so for our starter, 3 questions. Hit pause, have a go. When you're ready, hit play again and we'll go through them together. Okay, so what's the multiplier for a 5% increase? We're increasing by 5% from 100 plus 5. That gives us 105%, and that's a multiplier. That's going to be 1.05. Complete the statement. 5 kilometers equals, we've got to know our imperial to metric conversions. That would be 8 kilometers. What they've done here is they switched the question around. So to go from 8 to 40 is times 5. So I've got to multiply the 5 times 5, which gives me 25 miles. And on question 3, midday in London, time in Hong Kong is 2000 hours. Jay catches a flight at 03:30 hours. Expected travel time is 8 hours and 20 minutes. So what's his estimated arrival time? Okay, well, he leaves at 03:30 and he takes 8 hours and 20 minutes, giving us a total of 11 hours and 50. So he'll be arriving 11 hours 50, but this is still London time. Hong Kong time is 8 hours ahead. So we need to add that 8 hours on, and that takes us to 1950 hours, which is also, you can write as 7:50 p.m. Okay, so hit pause, make corrections and RAG rate your work. Once you're done, hit play again. And we'll look at independent events. Right, independent events. So we're considering the probability then of throwing a double 6 with 2 dice. A 6 and a 6. Now, what we can do is draw what's called a sample space diagram. So we make a table out of all the possible outcomes even, and count what we want. So here's our table. We've got the blue dice with you can have 1, 2, 3, 4, 5 or 6, and the red dice with the same. Now the outcomes on both dice at the same time, we add them. So 1 add 1, if we get a 1 and a 1, we get 2 altogether. A 1 and a 2 gives us 3, 1 and a 3 gives us 4, and so on. Now there are 36 possible outcomes when we throw 2 dice together, and we get them all by summing all of these possible outcomes. Now we want a 6 and a 6, so a 6 here and a 6 there will give us a 12 altogether. Chance of getting a 12 is 1 out of 36. Okay. Now they're independent events, so there's another way we can look at it. If we look at this, call this on the blue dice, the chance of getting a 6 is 1 out of 6. On the red dice, the chance is the same. So for 2 dice, if we multiply 1 out of 6 by 1 out of 6, we get the same answer, 1 out of 36. So we can draw the sample space diagram. At the same time, we can work it out using the probability of the independent events. Okay, what I need you to do is to make some notes. So I want you to sketch the sample diagram, giving us the probability of a 12. and then also make some notes on the single throw and then the 2 dice. So hit pause, make some notes. This is called a sample space diagram. And that's 1 out of 36. Good. Okay, for this this game, we've got 2 fair dice rolled, and the score is found by multiplying. So it's important. Sometimes the score is found by adding. In this case, it's found by multiplying the numbers together. So it wants you to copy and complete the table, show the possible outcomes in the table, and then use your completed diagram to find the probability of getting a score of 12 and the probability of getting a score of 23 or more. So hit pause, have a go at this question. Once you're done, hit play again, and we'll go through it together. Right, so if we're multiplying the options, 1 times 1 gives us 1, 1 times 2 is 2, 1 times 3 and so on. When we move to the next row, 2 times 1, 2 times 2, 2 times 3. So hopefully you've managed to complete all the possible outcomes there. Again, there are 36 possible outcomes. The results are different because we're multiplying the results on our dice. Question B, use your completed table to find the probability of getting a score of 12. So it's a score of 12 exactly. Now we've got a 12 there, 12 there. So those are 4 12s, 4 out of 36. So we can write 4 out of 36 like that. And hopefully you've simplified it to 1 out of 9. And then part C, find the probability of getting a score of 23 or more. So 23 or more than 23. And these are possible outcomes there. And there are 6 of them. So it's 6 out of 36, which we write as 6 out of 36 or 1 out of 6. Okay, so hit pause, make any corrections you need to, and we'll look at another example. Okay, so we can use the sample space diagram on a variety of games. So in this game here, we've got 2 spinners. Okay, so we want the probability of getting a 2 on the blue spinner and a 4 on the red spinner. So a 2 on the blue spinner, there are 2 2s out of 5 in total. And a 4 on the red spinner, there are 3 4s out of 6 possible outcomes. Okay. If we multiply those, we get 6 out of 30. So 2 out of 5 here. We're getting a 2 and 3 out of 6 here, which is equal to a half. If we multiply 2 out of 5 by 3 out of 6, we get 6 out of 30, which is 1 out of 5. So, is it right? What we can do is construct our sample space diagram and check. So these are the possible outcomes on the red spinner. 1, 2, 3 4s there and a 5. And on the blue spinner, 1, 2, 2, 3 and 4. And our possible outcomes when we add those results together are so. And we've got 1, 2, 3, 4, 5, 6 by 1, 2, 3, 4, 5. So 30 possible outcomes. So how many of them will give us a 2 and a 4? So those are the 2s. and 4s will give us 6 altogether. So we got 6 out of 30. So you can use either method. You can use either the sample space diagram or multiply the probabilities to get the correct answer. Okay, so have a look at this question. Rebecca has 9 coloured beads in the bag. 4 are red and the rest are blue. So it's going to be 5 blue. She removes a bead at random from the bag, notes the colour and then replaces it. Now that's important. Because it's being replaced each time, then we're going to have the same number whenever we're selecting. And then she chooses a second bead. Calculate the probability that she chooses 2 red beads. Well, for part A, probability of a red and a red is equal to probability of a red the first time is 4 out of 9. And then she replaces the bead, and then the chance of picking a red bead again is 4 out of 9. So we end up with 16 out of 81. And if we look at B, it says a blue bead first, followed by a red bead. So we've got a probability of a blue and a red. That's going to be equal to, probability of a blue is 5 out of 9. Multiply the probability of a red, which is 4 out of 9. Which gives us 20 out of 81. Okay, so hit pause, copy the example down. Once you're done, hit play again, and I've got a question for you to attempt. Right, so it's questions for you. Read, have a go. When you're ready, hit play again and we'll go through the solution. Okay, so Peter and Rebecca have a bag of red and blue beads each, as they're shown below. They remove a bead at random from their bags, and Peter selects first. So, A, what's the probability that both beads will be red? So, A, you should be writing P, both red, or red plus red, red and red. So the probability of a red bead from this here is going to be 3 out of 8 times the probability of red is going to be 1, 2, 3, 4. It's going to be 6 out of 9 here. And that gives us 18 out of 72. Remember, it says here answers in simplest form. If we simplify it, 18 goes into 72 4 times, so 1 out of 4. And then B, probability of both blue. That's going to be equal to 5 out of 8 here, times 3 out of 9 from here, and that gives us 15 out of 72, which we simplify to, we divide by 3, top and bottom, we get 5 out of 24. And for C, got a probability of red and blue. The probability of red is 3 out of 8 from Peter's bag, and the probability of blue from Rebecca's bag is 3 out of 9. Work that out, get 9 out of 72, and 9 goes into 72 8 times. Okay, so hit pause, make any corrections necessary, and once you've done that, I've got some classwork for you. Okay, for classwork, I want you to start from question 3. Okay, we're not doing 1 or 2, you start from question 3 and you work your way through to 5. So that's only 3 questions, and then developing fluency up to question 4. So, like I say, we start on question 3, on page 599. Okay, Good.